This video is going to be going over vertical and horizontal translations of functions. So a vertical shift is when you take a function and you add some kind of output to the outside of that function to move the function up or down. If k is positive, then the graph is going to move up. If k is negative, then the graph will move down. So if I have this function, it says it's the cubic function, and I add 1 to all of the outputs, that's going to make my y values increase. So let's look at this function here. So to regulate temperature in a green building, airflow vents near the roof open and close throughout the day, and the area of open vents V in square feet is given throughout the day in hours after midnight. During the summer, the facilities manager tries to decide if it's better to regulate temperature by increasing the amount of open vents by 20 square feet throughout the day and night. So our new equation, maybe we call it nu of t, is to take v of t and to add 20 to each and every output. So all that's going to do is take your graph and increase each and every output by a value of 20. We also have horizontal shifts because we have both an x and an y axis. And notice a horizontal shift is going to happen when you actually have something on the inside. So your horizontal axis is your x-axis. And so if I'm going to be making shifts along that axis, then they need to be associated inside my function with my x value. So I like to think about inside affects your inputs. Also, since they are inside, they behave opposite kind of what you would think. Notice this is an f of x minus h, and if h is positive, then the graph is going to move to the right. So if the graph is negative, or if h is negative, excuse me, then the graph is going to shift to the left. So notice here in this case, if I plug this in to the minus situation, okay, h is negative, so because h is equal to -1, I'm just rewriting this here. So instead of that positive, I'm writing it in this notation. That means h equals -1. So when I see f of x plus 1 on the inside, I need to know that that's actually going to shift to the left by 1. And so notice each and every value here goes to the left 1 because h is -1. Same problem that we looked at before, but let's look at in the autumn, the facilities manager decides that the venting plan is just starting too late and he wants to begin everything 2 hours earlier. So all that's going to happen is each and every data point is going to happen, let's see, maybe here, 2 hours earlier. Like that. So you're taking each and every data point and shifting it 2 hours to the left. Well, in that case, that means that h is equal to -2, and so maybe we call this like autumn. Well, that's going to be v of t minus, and then h is -2. So v of t plus 2 moves this v of t function to the left 2, even though there's a plus on the inside. Okay, the equation is t or x minus h. And so I like to think about if you're inside here, you're going to do the opposite of what the sign kind of tells you to do. And so you're going to shift to the left if it's positive, right if the sign inside is negative.